For decades, Venus, our closest planetary neighbor, held a peculiar secret. Imagine trying to set your watch to a planet whose day length seemed to whimsically shift, sometimes by as much as 20 minutes with every single orbit around the Sun. 20 minutes might not sound like much in the grand cosmic scheme, but for scientists meticulously charting the heavens, it was an infuriating, persistent anomaly. This wasn't just an academic curiosity, it was a fundamental challenge to our understanding of planetary mechanics, a puzzle to solve if we ever hope to truly understand, let alone visit, that scorching, cloud-veiled world. This shifting, elusive nature wasn't just an astronomical quirk. It posed a very real hurdle for future space exploration. Imagine sending a multi-million-dollar spacecraft across millions of miles, aiming for a precise touchdown. Every variable demands extreme accuracy. A discrepancy of just 20 minutes in Venus's rotation, accumulated over vast distances and times, could mean your lander misses its target by 20 miles. 20 miles might as well be a different planet when you're aiming for a specific geological feature or a unique sampling point. Such an error wouldn't just be an inconvenience, it could severely impact or even doom an entire mission. The stakes were incredibly high. It was this profound challenge that spurred a dedicated group of scientists to embark on a decade-long research mission. Their approach was ingenious and remarkably persistent, using radar, bouncing powerful light waves off the planet's surface. Imagine firing a beam from Earth, letting it travel millions of miles, penetrate Venus's thick clouds, strike its surface, and reflect back. By carefully analyzing these echoes, scientists could glean astonishing information, much like how bats use sound to map their surroundings. This decade-long radar campaign wasn't just about day length, it was a comprehensive planetary deep dive. By studying subtle distortions and timings in the returning radar signals, the team precisely measured Venus's axial tilt, crucial for understanding any climate and seasons. They also inferred the size and state of its core, much like ultrasound. Most critically, they finally determined how long Venus truly takes to complete a single rotation on its axis. It was a monumental task requiring cutting-edge technology, immense patience, and meticulous data analysis for 10 long years. The findings, emerging after a decade of diligent work, were revelatory. What the research team discovered fundamentally rewrote our planetary almanac for Venus. They confirmed one day on Venus is in fact the equivalent of 243 Earth days, plus some consistent, measurable change, now reliably accounted for. The previous puzzling discrepancies, that frustrating 20-minute wobble, were finally elegantly explained. The answer lay not within the solid body of the planet, but within its incredibly dynamic, powerful atmosphere. Venus is shrouded by an unbelievably thick atmosphere, primarily carbon dioxide, where winds whip around at phenomenal speeds, far faster than the planet rotates beneath them. These fast-moving, high-altitude clouds create an atmospheric drag, exerting a subtle yet significant torque on the solid body of Venus. It's like a gentle cosmic nudge, influencing and slightly altering the planet's spin. This interaction between the atmosphere and the solid planet was the source of the apparent 20-minute variation. With the radar data, scientists could finally disentangle the true rotation of the solid planet from this atmospheric influence, providing an accurate, stable figure for Venus's day. This discovery is more than just a scientific footnote, it's a profound step forward in our quest to explore the solar system. Knowing Venus's exact spin and orbital length removes a significant hurdle for future missions. We can now plan spacecraft trajectories and landing sites with unprecedented precision, confident our robotic emissaries will touch down exactly where intended. It's a testament to sustained scientific inquiry and the dedication of those who patiently unravel the universe's most intricate puzzles. It reminds us that even our closest neighbors can hold surprising secrets, and that sometimes answers lie not where we expect, but in the subtle, dynamic interactions between a planet's layers. This decade-long effort to crack Venus's shifting day wasn't just about measuring, it was about truly seeing, truly understanding, and setting the stage for humanity's next giant leap. We've explored the challenge, the decade-long dedication, and the remarkable breakthrough that has redefined our understanding of Venus's day. What aspects of planetary science fascinate you the most? Share your thoughts and questions in the comments below. And if you enjoyed this journey through scientific discovery, please consider following for more stories from the frontiers of knowledge.